Hello and welcome to the lecture for Chapter 8. I'm going to try to get through all of Chapter 8 in one lecture rather than splitting it up, so stick with me here. So we're going to talk about in Chapter 8, first of all, we're going to talk about death spirals. I think you saw that term come up quite a bit in this chapter. I'm hoping there's at least one most significant sentence that involves the phrase death spiral, but I'm going to talk about that. That's when an allocation scheme can cause damage to a company and cause decisions that aren't in the best economic interests of the company. Then I'll talk about allocation of service department cost, and we'll cover three different methods, and then I'll talk about joint costs, so that occurs in a manufacturing process. I'll talk about that. It's also a type of allocation problem. So a death spiral, that occurs when a company has large fixed cost of a common resource. And I think the book used an example of a telephone system that they install that has a large depreciation cost. And they allocate that across all the departments based on number of phones or something like that. But they allow the departments to opt out. They give them a choice of going with an outside service. So when some departments say, well, this depreciation is causing it to be a very large cost and I could get that more cheaply outside, they opt out of it to save their department money. And so then they recompute, the company recomputes the charge for this phone system, and now they're allocating that same amount of depreciation over fewer departments. So now they increase the charge that they're assessing those remaining departments, which cause more to drop out. And this continues until there's nobody left using the phone system, and they've got this expensive phone system with nothing to do with it. So that can happen. Some possible solutions to that. So one is you could charge users for only the variable cost, but not the depreciation, and look at the depreciation or other fixed costs as a company-wide expense not to be assessed to departments. That's one way to do it. Or you could have some measure that allocates some of the fixed costs, but not all of them. Or you could tell departments that you're not allowed to choose an outside service, that you have to use what the company provides in the interest of the overall company. I've worked at companies that did that for sure. So why do we allocate service department costs? Well, first of all, if we don't allocate costs, then there is nothing to mitigate their use. And so anything that's free, people want as much of it as they can. So if I told all of my departments, we supply cell phones to all the employees free of charge, no cost assessed for usage, no cost for the phones themselves, well, you can figure out that there would be multiple departments that figured out that every employee needs 2 or 3 phones, something like that. So if there's not a cost for it, people tend to use too much. And it reveals if there's an economic demand for the service. So if it's a service that I don't value, that doesn't move my department forward, then I'll decline it. If there's no cost associated with it, I have nothing to gauge that against. And then lastly, it allows us to compare internal services with external vendors. And there might be a point at which, hey, it doesn't make sense for us to, one that I've come across in companies before is doing our own payroll processing. What does it cost to have a person that's employed full-time doing payroll versus hiring an outside service to do it? So if we have a cost associated with it, then we can make that comparison a bit more easily. So service departments can provide benefits in a couple of different ways. Of course, they can provide benefits directly to operating divisions. They could provide benefits to other service departments, and they could provide benefits to themselves. So as an example, let's think about the human resources department within a company. So they handle all of benefits, probably, medical benefits and all that kind of stuff. They handle hiring, searching for employees and hiring new employees. They handle terminations and layoffs, those kinds of things. So when they do that, let's just take one example, hiring new employees. Obviously, they're part of the process for hiring new employees for all of the operating divisions. Well, they might also help hire employees for the accounting department, which is another service department, and maybe the engineering department, which is another service department. So they help those people hire employees. And then they help hire employees for their own department. So when they need new people in the HR department, of course, they participate in that. So we want to, it creates kind of a complex situation, as you can see by this diagram. And so there are three different methods for doing this allocation that get progressively more complicated. The first one we'll talk about is direct allocation. So in the direct allocation, the procedure is to ignore each service department's use of other service departments and what they do for themselves. So we're only going to look at the demand on service departments by the operating divisions and then allocate it accordingly. The benefit is it's easy. It's not hard to do the math. It's not hard to draw a picture and show people what you've done. The main disadvantage, in my opinion, is that it's really hard to argue that the operating divisions aren't bearing more than their share of that cost, right? Especially if you have some fairly large service departments, like a big IT department or something like that that has a lot of employees. If they're not getting assessed anything because they're a service department, well, that means more is being assessed because the operating divisions are bearing the whole burden of the HR department in that example. The other problem is, again, now that service is free to the other service departments. So again, whenever anything is free, people tend to overuse it. So place more demands on it than is realistic. So an example of that, we've got two service departments. This is from the textbook. The telecommunications department, $2 million a year, and then the IT department, $6 million a year. And you can see telecommunications, they help themselves to the extent of 10% of their cost. IT is 20% of their cost. And then the car division gets 40%, truck division gets 30%. It's important it adds up to 100. And then the IT department, they provide 25% of their services to telecom, 15 to themselves, and then 35-25. So when we do direct allocation, we're going to ignore the percentages for the other service department or ignore the percentages for themselves. So in this case, cars are going to, they use 40% of the telecommunications. Let's look at that example. Trucks use 30%. So cars are going to get 40% divided by 40 plus 30%, or 4/7 of the cost. And trucks are going to get 30 divided by 40 plus 30, or 3/7. So that I'm allocating 7/7. I'm allocating 100% of the telecommunication cost. With the IT department, cars use 35%, trucks use 25%, so a total of 60. I add that up and I get 7/12 and 5/12 if you do the math there. So then I can do the math. I can apply that to the for telecommunications to 2 million. I can give 1,143,000 to cars and 857,000 to trucks, and I can add that up and see that it does equal 2 million. The same thing with IT. 7/12 of 6 million is 3.5 million. 5/12 is 2.5 million. That adds up to 6. So I've allocated the full 8 million to both of those departments. So that's the easiest way to do it from a math standpoint. The next method, which I'd have to say is my favorite method, and that's to start with one service department and do all of the allocations. Okay, so allocate all of its cost to the remaining service departments and the operating departments. We ignore how much it gets for itself. And then I go to the next service department, do all the allocations, which is going to include some of the first service department, and keep going through all the service departments that way. So the order in which you do it can make somewhat of a difference. So you could do it a couple of different ways. One is to use cause and effect. So which department is doing the most for other service departments. That would actually be number 2. So cause and effect would be which departments affect the most other departments. 2 would be the most other departments that are serviced. And then 3 is just total budget amount by dollars. So some of the advantages there is it does put a price on what service departments use of each other's services. So that could mitigate the use of it to some extent. Some disadvantages you could have, it is a little bit different than opportunity cost, so it's not a perfect version of what the cost is, and it could either benefit some departments or harm other departments. the way this looks is, in this case, we have Service Department 1. We're going to allocate that to Service Department 2 and Service Department N. Then and also to the 3 operating divisions. And then I take what is left in 2, I allocate that to N into the service departments or the operating divisions, and then I allocate N to the operating divisions. So I step through and do them one at a time. So the example from the book, the one I took here is the first doing the telecommunications. So the thing to look at here is telecommunications. When we looked at the percentages, it gave 10% to itself, 20% to information technology, 40% to cars, and 30% to trucks. So when I add up 20 plus 40 plus 30, that's 90%. So I'm going to take the telecommunications and I'm going to give 20 of 90, or 2/9 of it, to information technology, to the other service department. I'll give 4/9 to cars, and then I would have put this down instead of 1/3, I would have said 3/9. So I'm adding up all the nines. That gives me 100%. So then the IT department, which is now going to contain some of the telecommunications department, I'm going to allocate that to cars and trucks like I did in the direct allocation method. So when you see in the bottom there where I do the math, this gives a more precise and more kind of justified cost to each of these 2 operating divisions. Ultimately, all of the costs need to go to the operating division. So you can see in the lower section on IT, I'm allocating $6 million plus $444,000, which is the IT department's portion of the telecommunications expenses. So the last method, reciprocal method, I want to walk through the math here, and it was found in the appendix. And I want to tell you right off the bat that I'm not going to test you on doing simultaneous equation solving, okay? Because I think it would make your head explode. So, but I do want you to be familiar with it, because you're going to work somewhere one day where they use this method, and you want to at least have some memory of, oh, I kind of remember what that is all about. And by the same token, you may run a company one day and you may decide this is the right approach, and so you need to know enough about it to be able to tell your controller to do it. So the procedure is to write equations defining the variable cost among each division, and then solve those simultaneous equations using linear algebra, and then I can allocate fixed costs based on their planned use of the capacity. So the advantage is it is the most accurate method. Okay, the disadvantage, it's hard to set up, it's hard to do the math, and probably most importantly, it's difficult to explain the results to people that don't understand the math, which is, I would say, probably in the real world, most managers. So whenever you have a cost allocation system that's affecting people, maybe affecting their bonus or how their performance is being judged, if they don't understand how it's arrived at, then it's a black box that a number comes out of, and they're going to argue against it. And so if you worked in a company like that and you went with this reciprocal method because it's slick and you like the math, you might find yourself arguing about it all the time. So the way that works is, first we have telecommunications cost. I'm going to take the total cost assigned from telecommunications, that's T. And for I, it's the total information technology cost. So I believe T was, let me look back at my notes here. I'm sorry. So telecommunications was 2 million and IT was 6 million. So for T, I'm going to say it's initial cost incurred plus 10% of that cost plus 25%, 0.25 of the I cost, the information technology cost. So I can, for initial cost incurred, that was 2 million. So I've got T equals 2 million plus 0.1 T plus 0.25 I. So I can do the same thing for information technology. I equals the initial cost incurred plus 0.2 of T plus 0.15 of I. And I can insert that 6 million for I to get the equation that you see here. So now I've got 2 equations. I got the equation for T that contains the variable T and the variable I, and I've got the equation for I, which includes the variables T and I. So now I can solve those simultaneously. So I can get the T's on, I can start with the technology one, or the telecommunications one rather, and I can take that 0.1 T and subtract it from both sides. So I get 0.9 T equals 2 plus 0.25 I, and I could divide both sides by 0.9 to get T equals 2 divided by 0.9 plus 0.25 divided by 0.9 I. And then I can simplify that to be T equals 2.222 plus 0.278 I, okay? Then I can do the same thing with I. Simplify it so that I get it down to exactly, or excuse me, I apologize. I can take I, and in place of the T, I can insert what I just determined T to be equal to, which is 2.222 plus 0.278 I. So now I have an equation that has all i's in it and no t's. So I can solve that now, get all of the i's on one side, all of the numbers on the other side, and I can determine I equals 8,000,000.112. Now that's kind of a meaningless number at this point, okay? I can substitute that into equation 3 and solve for t and see t equals 4.475. So then I can do this where I do the allocation. So the service department allocations for telecommunications, I have that negative 4.475 that we just calculated. So 10% of that, 0.448, they rounded, is going to go to telecommunications, 20% to information technologies, 30% to or 40% to cars, 30% to trucks. And I can see that equals 4.475, which offsets the negative. I do the same thing with 8.112 for the IT, and now you can see here in the vertical columns, I've allocated all of the telecommunications and information technology columns. They add up to 0, and I've got fully loaded cost in cars and trucks. So again, I wanted to walk through it so you knew kind of how it worked, but I'm not going to ask you to do that on a test. The last thing I want to talk about are joint costs, and joint costs occur not in the assembly process. So assembly is bringing a bunch of things together to make one final product. The joint costs occur in a disassembly process. So the example they used in the book is we have a chicken, okay? And maybe it's a plucked chicken ready to be dismembered. So I hope any of you that are vegans aren't disgusted by this example. So that whole chicken reaches a split off point and it becomes fillets, it becomes drumsticks, and it becomes wings. There's some extra costs to maybe trimming and packaging those different products, and then they have different selling prices. So the trick here is how much of each of those products do we use to allocate that $2? Because that $2 cost of the chicken is inherent in the parts of the chicken. So I used to work in a company that had a sawmill, so we had this very same thing. Logs would come in and we would disassemble a log into 2x4s, 2x6s, 4x4s, different types of lumber. And in that case, we used volume, cubic volume of wood, to allocate the cost to the cubic volumes of the product that came out of it. That can work in some cases. In other cases, it creates distorted costs that cause you to make bad decisions. In this case, they did it that way, I think based on weight or something like that. And it created the death spiral where chicken wings look like a loser, so they stopped selling chicken wings. Well, that just means that the $2 now is going to be allocated completely among fillets and drumsticks, so they bear a bigger cost. Now maybe one of them becomes a loser. So you end up having a death spiral where you think you're just better off throwing the chicken away. So a better way to do it that they talked about, well, I'll come to that in a minute. So the key question in these kinds of processes is, do I sell it at the split off point, or do I process it further and add more value to it? So in this case here, the best way to do that is to consider joint cost as a sunk cost and not take them into account, and just look at the incremental cost versus the benefit, the price that you get for that. And if what you get for it is greater than the incremental cost, then that's a better way to do it. So the best way to allocate joint costs, the book talks about a couple of different ways, but this is the best way, so I want to focus on that, and that's net realizable value. So the net realizable value is a selling price for a part of the product that you create minus the incremental costs, so the costs that are incurred after the split off point. That's the net realizable value. So the best way to do it, first of all, if the net realizable value is negative, then your best option is to throw that part of the chicken away at that point, or sell it as scrap and use that to reduce your overall $2 cost, but not to process it further. So the best way to allocate it is to allocate it based on positive net realizable values. So in this case here, I have the selling price in total, okay, and then I have the selling price for fillets, drumsticks, and wings, and I have the cost beyond the split off point. So I've got net realizable value of $1.60 for fillets, 76 cents for drumsticks, and 14 cents for wings. So I can take that total, and I could then take the joint cost of $2, and I can give fillets a percentage that is equal to $1.60 divided by 250, the total. So I'm giving it its allocation based on NRV. Drumsticks would get a fraction that is 0.76 divided by 250 times $2. So you can see now they're all getting part of that $2 cost, but it's relative to their net realizable value. Using this method is going to give you a better picture of what the profitability of each of these products are and keep you from dumping something that shouldn't be dumped. So I hope this lecture was helpful to you. As always, if you have questions, don't hesitate to shoot me an email or give me a call. Bye-bye.